Hi everyone, myself Dr. Lakshmi Prasad, working as a professor in CSC in Institute of Aeronautical Engineering, Hyderabad. In this video, I'm going to discuss about what are the various basic concepts of numerical integration. So, very first thing is that numerical integration. So, this numerical integration is going to be classified into two categories. So very first thing is that integral calculus. So it should be a branch of calculus which is going to be deals with the functions to be integrated, and this integration is nothing but it should be the reverse process of differentiation. And this in this one, so I have to use the function to be integrated, and which is going to be referred as integrand, while the result of this integration is called as integral. And at the same time, this integral is the equivalent to the area under the curve. Okay, so in numerical integration, so we have some of the branch of this numerical integration, what we call as integral calculus. So which is going to be deals with the functions that is going to be integrated. And this in this integration, so it should be a reverse process of this differentiation dy dx. So this function is to be integrated, what we call it as an integrand. So whatever the function are going to be integrated, so that should be what we call it as integrand. And the result of this integration, what we are going to get, that should be called as an integral. And here, this integral should be equivalent to the area under the curve. Suppose if I am going to have a function y is equal to f of x, and within the interval of a to b, so the area what is there inside the curve, that one what we call it as the integral. So this integral symbol is going to be elongated as that should be denoted as sum. So it was introduced by Limbich, so which was named as an integral calculus as calculus summatorius. So this integral numerical integration is going to be carried by numerical methods, and there are different three types. So first thing should be trapezoidal rule, and second one is Simpson's first rule, and Simpson's second rule. So this integration is an elongated as S denoted sum, which is going to be or named it as a calculus summatorius. Normally, this numerical integration is going to be classified into three types, what we call it as a trapezoidal rule, Simpson's first rule, and then Simpson's second rule. So this numerical integration, then other thing what we call it as a definite integral and indefinite or primitive integral. So this definite integral is going to be defined by the limit values of a and b of independent variable. So whereas indefinite or primitive integral is going to be have no restriction which is going to be imposed on the independent variable. So this one is going to be denoted as integral f of x ds within the interval of a to b here. So definite interval or integral, so which is going to be defined by the limit values in b of the independent variable, and this independent and primitive integral, so which is going to have no restriction that is going to be imposed on its independent variable, and this should be denoted as like this, integral f of x dl. This should be of integral. This should be the lower limit value, and this should be the upper limit value. So trapezoidal rule, so it is going to be applicable for equal intervals, and the error is going to be order of x square, and the accuracy is going to be improved by increasing the number of intervals and by decreasing the value of h here. So in this rule, y of x is the limit function of x here. So in general, this trapezoidal rule should be less accurate when compared to the Simpson's rule. Okay, So this trapezoidal rule means it should be only applicable for equal intervals, and it should be the error of the order should be h square, and this accuracy is going to be improved by increasing the number of intervals and by decreasing the value of h here. So in this rule, what one can able to call y is called f of x is the function of x. So in general, this the trapezoidal rule should be less comparative or less accurate when compared with this. So that may be approximating the area under the curve. So this should be something different here. So how we are going to make the area under the curve. So in this case, sometimes the area under the curve cannot be found through integration. So this may be because we can't find the integral value of equation of the curve, or because we need to find the area under the curve produced for experimental data. So in these cases, we can use a method to approximate the area under the curve. So one such method is going to be called as a trapezoidal rule. So normally this works by dividing the area under the curve into trapeziums and then calculating the areas. So sometimes the area of the curve should not be integration. So what I'm going to say that is, so we have to this may be happen. We can't find the integral of the equation of the curve, or because we need to find the area under the curve. So in these cases, we need to find and approximate the area under the curve. One such method is going to be called as a trapezoidal rule, and this works by dividing the area under the curve into various trapeziums and then calculating the areas. So normally the area of going trapezium is going to be given by the equation of into a plus b by h. So if we take in representation like this, so this is A and this is B, half of that, and this the height is going to be considered. Similarly, if I'm going to consider like this, so this should be A and B, and the height should be considered as. So to demonstrate this method, so consider the area under the curve. So let it be like this, so which is going to be given y is equal to x square plus 1. So the more trapeziums is that, so the area is going to be divided into more accurate than the estimate. Suppose if we want to find the area under the curve y is equal to f of x between x is equal to a and x is equal to b. So at that time, what I'm going to say that is we can able to divide the area into 4 trapeziums of equal with h. And the parallel sides of 4 trapeziums are going to be given by 5 coordinates. Let be like y0, y1, y2, and y3, so on. In general, this if there are n trapezium, there will be n plus 1 ordinates. So most of the trapeziums area is going to be divided more accurate in order to estimate this value. Suppose if I want to find the area of the curve y is equal to f of x. So this is the curve initially what I'm going to have, and I want to find the area in between them. So in between x is equal to a and x is equal to b. So for this, what I'm going to have to divide this region under the curve into different trapeziums. So where and then the sides are going to be given by the symbols like y0, y1, y2, y3, and y4, and this height should be the height of this trapeziums, what I said. And this one is going to be estimated by equation of into p by h. So that means half into y0 plus y1 divided by h. So if I'm going to consider this trapezium, similarly if I'm going to consider this one, is going to calculate as half into y1 plus y2 by h, like this. So the approximation area using the trapezoidal rule is going to be given by, so integral f of x dx, so half into, so y0 plus y1 by h, that's not what I said, and similarly one trapezium value is this one, and if I'm going to consider another trapezium value, so half into y1 plus y2 by h, and another trapezium. Like this, I'm going to be estimate the value of various trapeziums. So if I'm going to simplify this equation, so by making the half h as a constant here, so then I'm going to get the values of summation of all the coordinates y0 plus y1, y2, and so on. So if I'm going to set like this, if I simply further modify, so then half of h y0 plus 2 y1 into y2 to y3 and y4. So the ordinates has going to be spaced out evenly so that the width of the trapezium should be same. So therefore for n trapeziums of equal height, h is going to be given by, so h is equal to b minus a by n. So n should be the number of values. So this in general, this trapezoidal group of n trapeziums is going to be given by integral f of x to dx. It should be half of h into y naught plus 2y1 plus 2y2 and so on to yn minus 1 up to so on n. So by make use of this trapezoidal rule with four trapeziums to estimate the value of whether this is an overestimate or underestimate of the actual area we want to find out. So how can I able to do that? So for this, what I'm going to have a function f of x is equal to 1 by x. So if I'm going to make an integral of 1 to 2 for 1 by x dx, so how to I'm going to find it out? So the width of trapezium is going to be denoted by 2 minus b minus a by 4. So where n should be the number of values, right? So how many values I'm going to take 4. So the width of the trapezium is going to be getting as 0.25. So that should be the width of each trapezium. So by making the values of making the table of x is equal to 1 values of 1. So with the difference of 1.0.5, so 1.25 and 1.5, 1.5 plus 0.25, so 0.75, again 0.25, so that should be 2. So four values what I'm going to insert here. Then I'm going to find out the y value. So already y value is going to be given by 1 by x. So here if x is equal to 1, so y should also become, that should be the y naught value here. And by substituting 1 by 1.25 here, so I'm going to get 0.8, so then 1.5 by sorry, so 1 by 1.5, so 1 by 1.75, 1 by 2. So these are all the values of y naught, y2, y3, and then y4 values. So we can work out this area using this. So we already know the equation. So integral a to b f of x dx. So half of h into, so y naught plus 2y1 to y2 and so on to and y minus 1 plus yn. So by substituting this h as difference, so h value what I'm going to get is 0.25. So this 2.25 is going to substitute here. So like this, so 1 by 2 into 0.25, so half h, so making a difference here, so with the values of y1, so plus 2 y2 and then 2y1 plus 2y2 and so on. So this should be the y0 value, that should be 1. So 2y1, 2y2, 2y3 and 2y4. And then I'm going to get this value, so that should be approximately equal to 2. So we can able to show that the this is an underestimate and overestimate by switching the area given by the trapezium rule on the graph. So of the function y is equal to 1 by x. Okay, so like this we're going to estimate this values here. So how we're going to do that is, so this is going to be the trapezoidal rule. So we're able to find the width equation is going to be given by h is equal to minus a by n, and this trapezoidal rule is going to be defined by the equation integral to b f of x dx should be written as, so 1 half h into, so y naught plus 2y1, 2y2 and so on to y minus 1 up to yn. So by taking this example, so I'm going to take the function f of x is equal to 1 by x. I'm going to estimate the width of the trapezium, how much size it is. So for that I'm going to substitute b minus a by n. So n should be the number of values. So b is to 1, and that should be, I'm going to get 0.5 as the difference of each and every value here. So for this, for x is equal to 1, so I'm going to get 1.5, 1.25, 1.5, 1.72 like this. I'm going to get, and similarly I'm going to get these values. So I'm going, after substituting this y1, y0, y1, y2 values in the equation, I'm going to get the value. And after making this I'm going to get what should be the approximation. What I'm going to get is overestimate of this actual area. So how this we are going to estimate the regions of the graph, whether it should be overestimate and underestimate like this. Overestimate means in general if if the gradient of the graph is increasing over the given interval, then the area is going to be given by the trapezoidal rule with overestimate of the actual area. So if I'm going to have a graph, so this should be overestimate value. So if a graph like this should be overestimate. And similarly, if I'm going to have the gradient of the graphs is decreasing with the given interval of the area trapezoidal rule, then I'm going to get the curve. So this should be the underestimate value. So if the curve is like this, the area is going to get within the curve only. So that's why it should be underestimation. So like this, they are going to segregate the regions whether it should be overestimate and underestimate like this. So let us consider another example. So using this trapezoidal rule, so we're going to have four alternates to estimate two decimal place as the value of. So for this, how we're going to find, so integral 0 to pi by 3 value, so tan x dx. And then I'm going to find another thing also, state whether the estimation is an overestimate and underestimation of the curve area under the curve y is equal to tan x between 0 and the value is x is equal to pi by 3. So this should be the interval in between 0 and pi by 3. So this is the question they are allotted. And so how are we going to find? So initially we have to find this height of each trapezium. So for this one I'm going to get. So I'm going to take the three values, right? So that's fine. So h is equal to b minus a by 3 here. I'm going to construct, so pi minus 0 by 3. So that should be pi by 3 into 3. So that should be pi by 9. So this should be the difference value. So by taking the values of x equal to 0 starting one and difference of pi by 9. So pi by 9 by pi by 9 to pi by 9 and 2 pi by 3. So again 2 pi by 3. So 4 pi by 2 pi by 9 plus pi by 9. So 3 pi by 9. So 3 I'm going to get it out. So by substituting these values in the given function y is equal to tan x, so what is the value I'm getting? So 0 means 0 only. So y tan x, so the tan x value of pi by 9 is 0.364 and 2 pi by 9 that should be 0.8 and pi by 3 is 1.732. So once I'm going to get this equation, again we have to substitute these values in the given equation what I'm going to get. So this should be the trapezoidal rule equation. So integral a to b f of x dx, so half of x into y naught plus 2y1 and then 2y and minus 1 like this. So by substituting these values in the tan function like this, so what I'm going to get, so half into pi by 9 that should be half into pi by 9 that should be pi by 18. So this one pi by 18 plus y naught 0 and 2y1, so 2y2 and then 2 and minus 1 plus 1. So finally I'm going to get this 2. So that should be also less than 2. So this should be also, by checking this curve, the region under the curve should be denoted as or estimate also. And the next one is Simpson's first rule. So what it should be Simpson's first rule here. It was also called as Simpson's one-third rule. So normally it should be applicable for even intervals, and here the order is should be of h power 4. So in this rule, the y of x is the polynomial degree of 2 here, and then at the same time it is going to be uses 3 data points, right? So it is also known as Simpson's one-third rule, and it should be applicable only for the even intervals. So 2, 4, 6, 8, 10. So in between the intervals only you can able to use the Simpson's uh, first rule. and then error is going to be an order of h power 4, and this rule the polynomial degree should be 2, and then it is going to be used 3 data points. And Simpson's second rule, so it should be also called as Simpson's 3 by 8th rule. So the error should be order of h power 5. So in this rule, y of x should be the polynomial degree 3, and as it is applicable for the intervals, it should be of multiples of 3, and then it should be also use the 4 data points. So Simpson's rule. So Simpson's second rule is that it should be 3 by 8th rule. It should be order of h power 5. So in this rule, y of x is the polynomial of the degree, and in this rule, we are going to be multiple. So the Simpsons already you know that the trapezoidal rule. So the trapezoidal rule is going to be given by the equation. So integral x naught to x power n of x dx is going to be denoted as half of h into y naught plus y1, so plus, so 2 into y1 plus y2 plus 1 yn minus 1. So what is the equation for the Simpson's first rule here? So here the Simpson's first rule is going to be divided by h by 3 into y0 plus yn, and then 2y2, that should be, I'm going to consider only for the even intervals. So that's why it should be y2 plus y4 plus y6 under. And if I'm going to consider 3 by 8 rule, right? So 3 by 8 h, y0 plus y1, and 3 into I'm going to specify as v1, y2, y3, y4, so on, y5. So this should be the equation for the Simpson's second rule. Okay. So this Simpson's first is the 1/3 rule. So mainly it should be applicable for even intervals, and should be the order of h power 4. And in this rule, the y of x is the polynomial degree, and it is going to be used 3 data points. So when it comes to the Simpson's second rule here, so in Simpson's second rule, we are going to be used 3 by 8th rule, and the error should be of h power 5, and then in this rule, we are going to have the polynomial degree 3, and it is going to use 4 data points. And these are the 3 equations that is going to be used in the numerical integration. So here x naught should be the initial value of x, and y naught should be the initial value of y, and x and y are final values, and that should be the interval difference. So that should be defined by the equation x is equal to minus a by 2, and it should be the number of intervals. So what are the applications of this numerical integration if I'm going to see? So it is mainly helpful in finding the area, and it should also help in finding the allocating the centroid, and you can also find the arc length of the graph, and then you can also find the surface area of the solid as well, and then the volume of the solid figure, and then solve for the work done, and then solve for the moment of inertia. So the applications of this numerical integration will be of different different kinds of application where you can able to find the area of this. You can also find the location centroid, and then you can also find the arc length, surface, and the volume of this, and then you can also be able to solve the work done and show the moments of inertia. So some other also it is going to be used in finding the sectional area, water plane area, submerged area, and the longitudinal center of rotation, and larger center of rotation. So these are some of the various applications of numerical integration. So that means it is going to be used in finding the sectional area, and the water plane area, submerged volume, and then longitudinal center of rotation, and virtual center of rotation. So these are the various numerical integration operations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.